Alright, we're back to the final part of the video, which is going to be U indefinite integrals U substitution. So, we have this problem. We're going to use substitution to solve it. So, U substitution is very simple. It's just, you're going to take one of the groups in this problem. For this case, it would be 4x minus 12x. And you're going to label it as U. Ooh, it's very simple. And from there, take the derivative of U. So the derivative of U, or du, is I think there's an issue with the problem. The Python problem I'm using right now. It's supposed to be 2. So, root of U, 8x minus 12. dx. Don't forget the dx part. That's good. Add at the end of every one. Now then, you're going to divide this by 8x minus 12. So du. For this problem actually, we can do it like this. If you notice, and the dx here, if you rearrange this problem, you get 4x squared minus 12x to the power of 4, 8x minus 12 dx, which is the same thing as du. So, what you do with u and du is you substitute them into the equation. So, this just becomes u to the power of 4, and then this just becomes du. Cool. And now you integrate.
Can we use one of your markers?
I only have, the other ones are dry.
Huh?
The other ones are dry.
The other ones are dry. That's okay. We don't really need the light. We just need it as a prop.
Okay.
Thank you so much. This one. Is there a one? Thank you.
Back to the problem. So, u4 du, we're going to integrate this into 1 over 5. As integration, you take, what's it called? For integration, you add to this plus 1, so u5, and then you divide it by whatever the big number here is, so 5, which will just be 1 over 5 u5. And du is, if we integrate, is lost. So, now we have this. And I believe this is our final number for integration. And now you can just plug back in u. So that would be 4x squared minus 12x over 5. Boom. Very simple, very easy.
Albert, here you go. Here you go. Thank you so much.
Thank you. Let's do 2 more practice problems and then move on to integrals with inequality of U substitution with definite integrals. Now, let's use some of the problems from the Howard University Applied Calculus Final Exam. So, the first one would be no, that's not substitution. substitution. That's just regular integral. So we're going to use instead 8x 4x squared minus 5. The power of 4. This is very simple. Again, u 4x squared minus 5. Du equals 8x dx. Now then, if you look into the problem, we can see 8x dx in the equation. So we're going to keep this the same, and we're going to reorganize this to 4x squared minus 5 for 8x dx. Now then, let's substitute u for du. Now, we can go straight to integration. u5 over 5 plus c. That's basically it. We can write it as 1 over 5 u5 plus c. Very easy, very simple. And that's basically it for u integration, for indefinite integrals. It's pretty simple, not as difficult as it is for definite integrals, which we're not going to get into with the other ones. So, as we know, definite integrals have numbers we associate with them. This is 2, 1. So, when you're doing definite integrals, you have to insert that into the equation through one of the two methods. I prefer the second one, which is FB minus FA, which is what we're going to use for this. So, if I were to say have, no, I'll just go straight to practice problems. I'll also be taking these from the exam. It's quite loud outside. Let's do this problem. I believe it's 2, 0. Nope, it's 0, 2. So, x squared over x cubed plus 1. Squared dx. Now then, for my u, I'm going to use x cubed plus 1 du 3x squared dx. So it stays pretty samey for a big chunk of this, right? Then we're going to divide that by, let's do 3x squared, so 1 over 3x squared du equals dx. We'll put that in the equation. 2 x squared over u multiplied by 1 over 3x squared, which is just x squared over 3x squared times u. Oh, forgot to put the 4 here. The 2 up here. 2. Now then, we could just cross these out, which would then become equals 1 over 3 u squared. q2, u minus 2 over 3 integral. Now then, before we continue, I'd like to mention this very important part of the process, and that is to convert 0 and 2 into aspects of u, which is very simple, but it should be up in the first exam. So all we're going to do is insert these numbers into u right here. So 0 cubed plus 1 is just 1. So 0 will now just be 1. 2 cubed is 8 plus 1, that's 9. Let's continue. So u negative 2 over 3 plus 1 is u negative 1 over negative 1 times 3, which what would it be? Times addition. No, I made a mistake. Okay, let's go back a little bit. So, here. We're going to actually over 3. Then we're going to do multiplied by u negative 2 over 1 integral. Remove this to the outside. 1 over 3 minus 2 over 1, but just u minus 2. No use for the 1. Boom. And now we can integrate without issue. So we're going to do u minus 1 over minus. Alright, this is the final part of the video. I solved this problem earlier, but then I realized I wasn't recording, so we're gonna do it again. So, this is the problem. 3 4x, 3 parentheses 4x plus x4, parentheses 10x squared plus 5 plus x to the power of 5 minus 2, 6 dx. For our u, we're going to use 10x squared plus 5 plus x to the power of 5 minus 2. du is going to be 20x plus x4. Simple enough. dx. Now then, divide by 20 plus x4. du is going to be x4 plus 20x. Cool. We're going to split that back into the equation. This is just u. And now we have 1 over x4 plus 20x du. Now then, what we're going to do is we're going to multiply this to this. So that will give us u to the power of 6 and 3 over 4x plus x4 divided by x4 plus 20x. Something's wrong. Oh, I'm missing a 5. Should be 5x, should be 5x to the power of 4, and this should be 5x to the power of 4. There we go. Now then, let's continue. We're going to factor this out. So, that's going to become 12x plus 3x, 4 over 5x, 4 plus 20x. Now we're gonna cross these out. X4, X4, X, and X. That's going to leave us with 3 plus 3 over 5 plus 5. That's what 12 over 20 is 3/5, and 3/5 right here together. That's 6 over 10, which is just, again, 3 over 5. So, now we have 3 over 5 u 6. Add 1 over 6 plus 1, 3 over 5 times u7 divided by 7, 3 over 35 u7, or 3 over 35 with u7 on the outside. Cool. So we don't need this anymore, and we don't need all of this. I'm going to put. So now we define this in terms of u. Very simple. We're going to start with 0. 0. It's going to be 0, 0, minus 2. So now it's minus 2. Now we do 1. 10 plus 1 minus 2 is 9. Cool. 9. And now we have 3 over 35 9 7 minus 3 over 35 minus 2 7. And I'm not going to go fully solve this because I don't have a calculator, and there's some pretty big exponents here. It's just going to be 3 9 minus 3 minus 2 7 7 divided by 35. And for now, that's the final answer. And I hope this video shows my understanding of all the concepts of chain rule, implicit differentiation, and U substitution for both indefinite and definite integrals. It's the last problem I'm going to be doing. And thank you for your time, and thank you for being my teacher. Have a great summer break, Professor, and I hope to see you again next semester.